In this section, we're going to go over a lot of different operations with decimals and percent and rounding. And I'd like to first begin with how do you identify what order you divide? Because we know order of division is important. For instance, 4 divided by 2 is 2, whereas 2 divided by 4 is 1/2. Especially whenever we're given the instruction to divide verbally, how do we translate that into an actual expression? With our first example, we're asked to divide 65.175 by 8.25. Whenever it's phrased divide this by this, the number that comes first is in the top of the fraction. The number that comes second is in the bottom of the fraction. And whenever you're asked to divide something with decimals like this is just a case for your calculator. So you would get the calculator that you use for this class, and you would type this in. If you haven't done this before, you would type the top number first, click the divided button, type in the bottom number, make sure there's no typos in the decimal places, and we would get the value is 7.9. And for this whole notes video, I definitely recommend you have the calculator that you're planning to use on our exams, not on your phone, so that you can practice this and make sure you're getting the correct answers. Now, this answer ended up not needing to be rounded. It was perfectly just to 1 decimal place, but often we're going to have problems where the decimal continues either forever or to too many decimal places that we don't want to represent, so we need to round to certain decimal places. We're going to quickly go over just some rounding rules, and then we'll start seeing that in our later problems. Whenever you're rounding, it will say something like round to, for instance, the second decimal place. In that case, you find that second decimal place, and you always look to the right, okay, the next digit after it. Based on the value of that digit, you know whether you're going to leave it as it is or round up. So if the digit's less than 5, you leave it alone. So in our example, if I was rounding 0.453 to 2 decimal places, I would look to the digit to the right. Since it's 3, which is less than 5, I leave this digit alone and it rounds to 0.45. But if you look to the digit to the right of the decimal place you're trying to round to and it's greater than or equal to 5, then you round the previous digit up by 1. For instance, rounding 1.267 to 3 decimal places, okay, we figure out, okay, we're rounding to 6, the third decimal place. So we look to the right at 7. It's greater than 5, so this decimal place gets incremented by 1, so it's 0.127. Sometimes the phrasing will be round to 3 decimal places, 4 decimal places, it tells you exactly. And then sometimes it implies what decimal place by saying round to the tenths place, the hundredths place, the thousandths place. So you'll just want to know this translation. When it says the tenths place, that's round to 1 decimal place. When it asks you to round to the hundredths place, that's to 2. The thousandths, that's to 3. So that's the mental translation we'll need to make. So for each of these examples, we are going to, in the first example, round this number to a variety of locations. Okay, so 3 different rounding practices. And then in the next example, we'll round this. So let's round this one together, and then I'll ask you to pause the video and attempt this one on your own. If we're rounding 0.9175 to the tenths place, I know in my mind that's telling me to round to the first decimal place. So I'm going to underline the first decimal place, and then I look to the right. Since the number to the right is 1, which is less than 5, this number stays the same. If you want to show that you're rounding in your work, you would do like the squiggly, that means about 0.9. So 0.9175 to 1 decimal place is 0.9. Now to the hundredths place, we know that's to the second decimal place, so you would go over 1, 2. This is what we're curious about. Do we leave it as 1 or do we go up to 2? You look to the right. It's a 7, bigger than 5. So this digit goes up by 1. It's currently 1, so now it will be 2. So we're going to show I'm going to round that as 0.92. And now to the thousandth, we know that's 3 decimal places. I write down the original number. 1, 2, 3, that's the thousandths place. I look to the right. Now this is exactly equal to 5, But remember, the phrase is if it's greater than or equal to, then you round up. So this digit needs to be incremented by 1, currently 7. So now we keep the other digits alone, 9, 1, but now it's going to be an 8. I recommend you pause the video now and round this decimal to the tenths, hundredths, and then thousandths place in a similar way as we did before. When you've finished your work, unpause it and check your answer. Okay. Now working on our first problem, 13.4282 to the first decimal place to the tenths place. We look to the right, it's a 2, less than 5, so that stays the same, and it would round to 13.4. To our next one, we would round that, it's an 8, so this gets incremented up by 1 to 13.43. To the third decimal place, or the thousandths place, we look to the right and it's a 2, less than 5, so this stays as it is, 13.428. Now, whenever we think of decimals, another thing that we would think about is percent, which is just another way of representing a similar idea. Percent means per 100, and this is the symbol for percent. What we would want to remember is that 1% is 1 out of 100. So it's kind of, think of percent as parts per whole, 1 out of 100. So there's 1 part per 100, which would become the decimal. If you type this into your calculator, 0.01. And in this class, we're going to need to know how to convert between percentages and decimals to percentages. And later in these notes, we are going to go over how can we apply these ideas of percentages to solving word problems. In this explanation, we have how to change between percent and decimals. Here, it's starting with the percent and then ending up with a decimal. Whereas here we've got a decimal, and then we're going to be changing it to a percentage, and these are the steps lined out. If we're starting with the percent, and then we're going to a decimal, you would first find the decimal place in the percentage. What this might look like is if there's no decimal place visible in the number, then remember the decimal place is always to the right of the last listed digit. So if we were just looking at how to convert 97% to a decimal, in this portion, there's no decimal place listed, but we know the decimal place is actually implied to be to the right of the last listed digit, so it's 97 point, and if you want, you could write 0.0, or you could just leave it as 97 point. So we found our decimal place. Then you move the decimal places 2 places to the left. So it was here, and now it gets moved 1, 2, and 97% as a decimal is 0.97. Or if you prefer, 0.97. Both are equivalent. So whenever we're going from percentage to decimal, the value should get significantly smaller. And then it's just the reverse process from decimal to percentage. You start in the same place. Again, we find the decimal place. And then if we're going from decimal to percent, once we've identified the decimal place, we then move the decimal places 2 places to the right. So we're reversing our order. And the final result will be a percentage, so we do want to write the percent symbol. If we start with the decimal 1.45, to turn that to a percentage, we find the decimal place here. We move 2 places to the right, and then add the percent symbol, so it's 145.0%, or you could write it more efficiently as just 145%. Let's apply these techniques to our following examples. Here we're just asked to convert each percent to a decimal. We're given the percent, we turn it into the decimal. Step 1, always find the decimal place. Here in 98%, there's not a decimal place listed, but we know the decimal is always to the right of the last listed digit. So I found the decimal place, and then to go to a decimal, you move 2 places to the left. So what I'm drawing here is I'm kind of moving 1 place, and then moving another place. That's where the decimal is going to go. So the answer is 0.98. If you prefer, you could also list it as 0.98. I recommend you pause the video at this point and attempt these 3 remaining problems, and then unpause and check your solution. So I find the decimal place and I move to the left, not to the right. But again, there's nothing there, so I add in the 0, which means 3.4% as a decimal is 0.034 or just 0.034. Both are equivalent. For the next one, we have our decimal place at 0.3. Move 2 places to the left, adding in zeros as necessary if they're not currently there, and we would get 0.003 or 0.003. This last one, 178, the implied decimal place is there. Moving 2 places to the left would give us 1.78. Now we're going to practice the reverse direction. We're going to go from decimals to percentages. The difference here is now we're going to be moving 2 places to the right of the decimal place. And we should imagine in our mind when we go from decimals to percent, we're going to end up with a larger value because we're moving to the right. I find the decimal place, move it 2 places, and that would give us exactly the decimal point after the 6. So it would be 16. And since it's a percent, we do have to end with the percent symbol. Find the decimal place, move 2 places to the right. Okay. I recommend you pause the video, attempt these 2, and then unpause to check your solution. For the remaining 2 problems, we would get 237% after we move the decimal place twice. And then here, when we move the decimal place over twice, we would get 0.8%. Now we've talked about converting decimals to percents, but we know fractions can be represented by decimals. So the way to convert a fraction to a percent is you first convert the fraction into a decimal using your calculator, and then go through the procedure decimal to percent as we've just done above. So once we get a decimal representation, we move the decimal point 2 places to the right, and that's our percentage. So if we're converting 3/5 to a percent, we would first in our calculator divide 3 by 5, and that's 0.6 as a decimal. Now that we're going to a percent, we move the decimal place over twice. There's nothing here, so we would have to add in the 0, and then there's the decimal place, and we would get 60%. Pause the video and attempt this last one here. As a decimal, 15 over 8 is 1.875. Moving the decimal place over twice, we would get 187.5%. We're about to get into word problems that we can solve using this understanding of decimals and percentages, but first I want to go over how do you calculate the percentage of a number. If we were asked what is 15% of 60, the way you would answer that problem is you would first need to convert 15% to a decimal. Let's do that here. We know the implied decimal place for the 15 is to the right of the 5 because it's to the right of the last digit. Since we're going from percent to decimal, we're getting smaller, so we should move to the left. So 15% as a decimal is 0.25. Step 2, take the percent written as a decimal, which we just found. In our case, this is 0.15. And then multiply that by the number given. In this case, this is our 60. So we are going to write out 0.15 times 60. We would grab our calculators, type this in, and we would get 9. So the number 9 is 15% of 60. And a great way to check your work is if you ever form the fraction 9 divided by 60, you would get exactly 0.15. And we know 0.15, turning it to a percent, is 15% as expected. Example is categorized into the structure of finding a percent of a number. And you'll see the later examples also have kind of their word category. As you work through these problems, I recommend that you try to kind of take apart the context and ask yourself, what in particular is it asking me to figure out? Let's read this problem and see why it falls into the percent of a number category, like we just saw an example of before. A publisher requires that an author reduce the page count in her next edition by 18%. And one thing we might want to focus on in this word problem is it did say reduce. So in the end, the number of pages should be less than where we started in this last edition. Currently, there are 250 pages in the book, and we are asked how many pages must be removed from the book to fit this specification. So in this problem, we're not looking for the final amount of pages in the new edition. We're just asking for how much do you need to cut out. Specifically, the editor said we need to remove 18% of the current edition size. But the current edition was 200 pages, so we're removing 18% of 250 pages, which helps us see why this fits into the category of we want to find what is 18% of 250, and that's the number of pages we need to remove. To find the percent of a number, as we talked about previously, we would first turn the percent into a decimal. So there's an implied decimal place to the right of the last digit. So it's 18.0%. To go to a decimal, you move that 2 places. So it's 0.18. To find the percent of a number, you take the percentage written as a decimal, multiply it by the number given. So 0.18, remember when numbers are written next to each other, that's implied multiplication, of 250 in our calculator is exactly 45 pages must be removed. And that would be our answer. Now, what if we were asked a follow-up question, how many pages remain in the new edition? In this case, we would need to take the original amount, 250 pages, and subtract the amount that we removed, which we found to be 45, and we would get exactly 205 pages remain. So this isn't what we were asked in the example, but it's good just to see how we might take this problem even a step further. Our next example fits the category of what percent one number is of another number. A kindergartner teacher has submitted 6 of the required 50 class preparations to the principal of her school. What is the percent requirement the teacher has completed? In these cases, we would want to remember that the percent is always the part completed out of the whole amount available. And then to make sure it's a percentage, if you just do this fraction, it's going to be a decimal. And we know we can change decimals to percent by moving 2 places to the right. That's equivalent to multiplying by 100. So we could remember this formula. To find a percent, you take the part, divide it by a whole, and multiply by 100. So in this case, the part is the 6 out of the whole 50. So the percent that's completed is equal to 6 out of 50, which we would find in our calculator. That's 0.12. And then we would multiply by 100, and we would end up with exactly 12% completed. In our next example, we're asked to find the new value if we're going to mark up the price of an item that was originally at this price, and we want to increase the price by 15%. Now, just some context as we're reading this, when we hear the phrase mark up, we should expect our new price to be greater than the old price because we're marking it up, not marking it down. I recommend you pause the video, take a minute to think about what's written, strategize how to solve it, and try to find the solution, and then unpause to see if your work was correct. In this problem, we want to increase the price, but we don't want to just increase it by any amount. We specifically want to increase price by 15% of the original 3250. And this tells me if I could find the percent of this number, 15% of this number, then I could add that to the original price and I would get my final answer. This fits into the first part of category of percent of a number. We know the implied decimal point is there, so we would first turn it to a decimal, multiply it by the number given, use our calculators here, and this gives us our price increase should be $4.875, but it's increasing from what? It's increasing from the original price. So we would finish the problem by taking the price increase plus the original amount to get our new price, and we're going to assume this is in dollars, and that would give us $37.375. Now, even though they didn't tell us to round to 2 decimal places, since we know dollars are always given in terms of cents, 2 decimal places, it's implied, so we would want to round to the second decimal place. We see that the number to the right of it is 5, so this would be rounded up to 37.38 is the new price. And if we wanted to check our work, we could just see, is 37.38 15% more than the 32.50? In a similar way, we would take the 37.38, this is for our check, divide that by 32.50, and round it to 2 decimal places, it would be about 1.15. And this is correct because the 1.15 represents that the 1 is that you've got the whole amount that you were originally adding, plus 15% that we added on. So we kept the original and then just added 15%. So it works out. Now, our next example fits the category where we are finding a number that is a given percent of another number. A government employee working for a local government chooses 5% of a jury pool to question for possible service. After they've done this selection, it says they select only 38 people for the possible service. What was the original size of the jury pool? This is going to be a problem that I think is going to be useful to write out some information to help us kind of see the structure of the argument, and then we'll know where to go from there. So what happened is there was an original jury pool, which we can assume is larger than 38. Because to only select 5% and end up with 38, you had to be quite a bit larger. And what we were doing is we were finding 5% of jury pool. And specifically, we don't know the size of the jury pool. Anytime you don't know a certain value and you're going to have to find it, I recommend you give it a variable letter so that you can work with it. In this case, I'm going to call it X. And in the end, 5% of the jury pool was 38. So I could set up this equation. 5% of the number X ends up being 38. This is a slight reversal of the problems that we've been doing to this point. Normally, we were given the fact that we were looking at 5% of a certain number, and then we calculated to find this number. But now we've kind of got the missing pieces. So the way we would go through this is we would think about how would you do this problem normally, and just keep representing it by the variable X, and we'll end up with our final answer. If we were looking at just the left side, because the right side is fully simplified, we're just going to keep writing 38 until we're ready to solve. But we think about how do you find 5% of any number? Well, you first turn the 5% into a decimal. Decimal places here, move 2 places to the left. So this is 0.05. To find any percentage of a number, you then multiply that by the number. And in this case, we don't know what the number X is, but we can still write X as a placeholder. And we know the result of that from what it phrased is 38. So we know 0.05 times X, this is just another way to write multiplication, equals 38. And specifically, we're looking for the original size of the jury pool, but that is X. So we know we can finish this problem by solving for X. Whenever we're solving an equation, think about the different operations, adding and subtracting our opposites, multiplying and dividing our opposites. So we've got 0.05 times X equals 38. We want to get X by itself where we can say X equals something. So we want to move the 0.05 away, but we've got to keep it equal. It's currently being multiplied, so we would do the opposite operation, and we would divide by that. But what's done to one side must be done to the other side. Imagine two scales that are equal. You can't remove something from one scale without removing it from the other scale also to stay equal. At this point, we would get x is whatever 38 divided by 0.05 is. We would do this in our calculator. I recommend you pause the video and take that calculation. Whenever we type this into our calculator, we would get 760, and we know these were people on the jury pool. So the original size of the jury pool was 760 people. We're down to our last two examples of this video. An electronics store marked up a laptop from the store's cost of $1,200 to a selling price to the customer of $1,464. What was the percent markup? So in this case, we've got the original price and we've got the final price, but we want to find the percent. We could remember the formula that the percentage is always the part divided by the whole times 100. But in this problem, we don't yet have the part and the whole perfectly. But we've got enough information to find it. We know the original whole amount that we were marking up was $1,200. So we could replace that there. But what we would want to do next is figure out how much did we mark up. If we were at $1,200 and then we ended up with $1,464, we could find the exact amount of markup by subtracting them. This is how much we added to the price. When we subtract these two, we get that we had a $264 increase from the original $1,200. So this is the part that we increased out of the whole. So 264 divided by 1,200 all times 100. We'll calculate this in our calculator. And we would get exactly 22% markup. After finding this value, you could always check your work by thinking, is 22% of 1,200 added to 1,200 equal to 1,464? And it definitely is. Our final example is that the enrollment in a community college declined, so that made us think it decreased, from the original 12,750 students to the next year's of 11,350 students. Find the percent decrease, and then they told us to the nearest tenth of a percent. Whenever it says to the nearest tenth of a percent or something like that, you worry at that at the very end. Once we get our final answer. So once we get our final answer, we're going to round to, when it says tenth of a percent, we know that means 1 decimal place. But first, we've got to get to our final answer. To find the percent decrease, remember that we know the percent amount is always going to be equal to the part divided by the whole times 100. Now, the whole is always the original point. We originally started with 12,750. And we know we're going to multiply by 100. Now we just need to find the part. The part is based on the change from one point to the next. So if we started at 12,750, and then it ended up being 11,350, we always take later minus earlier. So that would be 11,350 minus 12,750, 12,750. And we would get there was a decrease of 1,400 students. And the negative number is expected because definitely to go from here to here it did decrease. So the part is negative 1,400. We decreased by negative 1,400 of the original 12,750 whole. After correctly typing this into our calculator, we should get negative 10.98039216%. but we were asked to round this to the nearest tenth, which we translate to the first decimal place. So we look to our first decimal place, and we look to the right, and the number is greater than 5. And additionally, the number that we would then round up is a 9. Now, if you add 1 to 9, that actually takes you to 10, but we're not going to write 10.110. That would not be correct. Whenever if you're rounding up a 9, you actually have to increase then the next decimal up. So this would round to about negative 11.0. So then this decimal place went up to the 10, so that goes to 0%. So we had a decrease of 11% in enrollment. That's it for this video. Thank you very much for your attention, and let me know if you have any questions.